All right, so this is pretty much what tomorrow's part of the final looks like. It has 20 questions. There's a few things that I put extra practice on the review that, like, there might only be one question on the final and there's 2 or 3 on here. So, all right, the first question is about length of an arc. This is at the top of the reference sheet, which you should have out probably your whole reference packet for the final, just so you are familiar with where things are. This is the arc length formula, it says right here. But this is the important piece here. The only way that these work is if theta is in radians. So if r is 11 centimeters, and theta is 80 degrees, we have to change it to radians, which is multiply by pi over 180. And then to find the arc length, you're just supposed to multiply r times theta. So S would equal 11 times 80 pi over 180. Type that in because it wants an answer to the nearest tenth. No need to reduce or anything. I got 15.4. Did somebody else get that? And that would be centimeters because it is a length. And remember, anything times radians, radians just goes away. Questions on number 1? Right. Number 2, let theta be an angle in standard position with the point negative 512 on the terminal side. So if you go left 5 and up 12, connect back to the origin, and it wants the cosecant. I hope this is not a tricky question anymore for most of you. That earlier when we did this on a quiz, it was didn't go well, but are you good now? The things you have to do would be Pythagorean theorem, and everybody's going to ignore the negative, right? That comes out 169, so the square root is 13. Read carefully. It says cosecant, which is the reciprocal of sine. So for most of you, if you just use sine equals opposite over hypotenuse, this would be hypotenuse over opposite, which would be 13 over 12. Please shout if I make a mistake. I don't want it on the video. Everybody good? All right, find the exact value, and I could ask you anything about the unit circle. So this particular one is cotangent. Well, tangent is sine over cosine, or y over x, so cotangent is x over y. So if we go to 5 pi over 3, which is right here, and we put the x over the y, we ignore the denominators because when we divided they'd cancel, and what is that going to simplify to? Negative square root of 3 over 3. Everybody good? Questions? Okay, it's not like a crazy negative angle that you have to convert and mess with, okay? It's just find an exact value, but it could definitely be a reciprocal function. All right, number 4 says if the cosine is greater than 0, everybody gets that means positive. Says the sine is negative 7/25, so the sine is negative. Guys, it lists them right on here. So if we need a cosine that is positive and a sine that's negative, cosine is positive and the sine that's negative, we're in quadrant 4. Everybody good? So this brings us to quadrant 4, and I don't care if you use regular number 4. So then if we sketch it in quadrant 4, if we draw a triangle with the x-axis, whose sine is opposite over hypotenuse, we'd have negative 7/25. The hypotenuse is never negative. Then you have to do Pythagorean theorem, which would be x squared plus 7 squared equals 25 squared. Somebody check, is it like 576 or something? And then when you square root, you get 24. Positive or negative? Depends on where it is in the unit circle or the quadrants, but that one went to the right, so it's positive. Everybody okay? So then tangent is opposite over adjacent, which would be negative 7/24. Again, I highly suggest you just ignore the negatives when you're doing Pythagorean theorem. Otherwise, you need a bunch of extra parentheses, and some of you forget them, and it just messes you up. Okay. Solve this trig equation for all solutions in radians. What's going on here, guys? What can we do here? Do not ever divide by a trig function. So don't move cosine over there and divide. Instead, we what? Take out a cosine of x. What's left? 2 cosine of x minus 1 equals 0. Everybody okay? When you divide cosine by cosine or pull it out, you get a 1 there. So it's minus 1 back there. So then if you set each one equal to 0, you have this equals 0 or this equals 0. If you solve this one, you'd have the cosine of x is 1/2. Now, what's the trick to this? Remembering what? Yeah, plus or minus 2 pi n. And there should be several solutions. There's shorter ways to write it, but we're doing cosine. Remember, it goes cosine sine. So we're looking for where is the x value 0? That's here and down at 3 pi over 2. So the easiest way is probably just for you guys to write pi over 2 plus or minus 2 pi n, 3 pi over 2 plus or minus 2 pi n. And then the places where cosine is 1/2 is here at pi over 3 plus or minus 2 pi n. And at this one and this one, which will be 5 pi over 3. There are definitely shorter ways to write that. Yes. For that one, yes, that would not work for this one. Yeah. They also, because it's cosine, it would be really easy to just write positive or negative pi over 2 and positive or negative pi over 3 because it goes up pi over 3 or down pi over 3, but that's not necessary. You can write it just like this and be fine. Any questions? All right, identify the number that changes the period and state the new period. All right, real quick, if we had A cosine B x minus C plus D, this one affects amplitude, and amplitude is always positive, right? If there was a negative there, you would take the absolute value. B changes the period, but the new period is 2 pi over B. C is a phase shift, left or right. And D is a vertical shift. Okay, so which one is affecting the period? Yeah, this mess in here, 3 pi over 5. So the new period is, well, it's 2 pi divided by that ugly number, which would be 2 pi times the reciprocal of that number. What is that going to reduce to? I don't know that it's that ugly on the quiz, but you don't have to graph it, so at least it doesn't matter how ugly it is, right? You don't have to find quarter points or anything nasty. I think it's a little better on the quiz, but I'd always rather the review was ugly than the final, right? Anybody have a question on that one? All right, so here it says identify the phase shift and the direction that changed the normal cosine into this. We just talked about the phase shift is this, okay? So it's pi over 6 to the left or right, guys? Anything in the parenthesis is the opposite of what it seems. This looks like it's minus, so it's plus to the right. Everybody gonna get that one right? All right, this is where I get a little nervous because it's worth quite a few points on the final. Quite a few, at the most 3. I don't even know if it's worth 3, but what is the amplitude? We're graphing this guy right here. So the amplitude is 4, so it should go up to 4 and down to -4. Okay, the period, well, B is 2 here, so the period is 2 pi divided by 2, which would make it pi. And then you have quarter points. Remember, quarter points is where you take whatever you've discovered the period is and divide it by 4. So in this case, it's just pi over 4, because the period was just pi. So we're going to need a value at pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, and that'll be 1 period, and it says you only have to do 1 period if you want. It's enough for me. All right, what do we have to know, though? Cosine versus sine. What is the cosine shape, guys? Yeah, starts at the max, and the sine shape starts at the midline. So this particular one is a cosine. So you would start at the maximum value of 4. The first quarter point would hit the midline. The next quarter point would be the minimum. The next quarter point would be the midline again. And the final quarter point would be the maximum. And these really should look like stretched quarter circles, but I'm not going to worry about it. If you were to continue in either direction, it would look like this, but you don't need to, guys. As long as you draw 1 period, I'm going to be happy. So the quarter points that I put on there were over 0, up 4, over pi over 4, it's at the x-axis. At pi over 2, it's down at -4. At 3 pi over 4, it's at the x-axis. And at pi, it's back at the maximum of 4. It says label. I think they meant like A, B, C, D, but I don't really care. As long as I can tell you went through those points, I'm good. Questions? I can make up another, actually I think I have another example. Oh, maybe not. There's a question like this on the test where you have to fill in all this great stuff. It says we have to give a sine equation. So a sine equation means we need to look where it starts. I mean, you could do a negative sign, but this is the shape for a sine equation. I think the first thing that would help us is to find the midline. To find the midline, you average. So if we have a 2 and a -4, we get -2 divided by 2. The midline is at -1. Would you've all got that right? Okay. So in my mind, I would find where it crosses the midline and goes up and call that the phase shift. So that I don't have to do a negative sign, but you could have also started over here. So if this is pi over 2, what's halfway to pi over 2, guys? Half of pi over 2 would be pi over 4. So this is at pi over 4. So that's the phase shift that I'm going to use, because that's where I saw that sine shape, and they said I had to call it a sine. All right, what else can you tell me then? Amplitude, well, the midline, the vertical shift was down 1, right? That was the midline. The amplitude is how far above and below that it goes. So from -1 and down to -4, that's an amplitude of 3, right? Any questions on that? Now, the period is a little hairy for some of you because I didn't count off all these, but pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This place that it ends here would be 5 pi over 4. But that's not the period, right? The period is how long it is. So from pi over 4 to 5 pi over 4 is just pi. And you could have just, for a moment, pretended that it was an upside down cosine. Look, it started here and ended here. That's a length of pi. Okay, it doesn't matter what you're calling it. The time it takes to start, you know, you could go from here to here, or you could go from here to here. As long as it finishes one cycle, that's the period. So the period is pi, which makes 2 pi over pi, the b value, which is just 2. All right, can anybody put it all together? Y equals? Okay. So if you were typing it in your calculator, you would need all these extra parentheses. For the sake of writing it down, you need at least parentheses around the x minus 4. Questions? Did I put an extra one of these on here? I feel like I did. It's kind of an ugly one, so I'll go through it kind of quick, but if you want a sine equation out of this, you might start over here. Say it's crossing the midline. Okay. I don't think it's this nasty on the quiz, but if this is negative, if this is 3, halfway there would be here, which would be 3 halves. And halfway to that, half of 3 halves would be 3/4. So this is 3/4, 3 halves, another 3/4 would be, this is 6 halves, 6/4, 9/4. Wow, that's hurting my head. Anyway, this is -3/4 over here. Where's the midline? Can anybody tell that? This is just a nasty example, but from -20 to 60 is 40 divided by 2. The midline is at 20. Does that work? Is that positive 20? And then down to -20 and up to 60 is how much either way? 40. So the amplitude is 40. The period is actually 3, and you could have just gone from here to here. Okay, it doesn't matter that it was a cosine shape. The period is 3. So B would be 2 pi over 3. The vertical shift is the midline, which is up 20. And the phase shift, I went left 3/4. So again, this one is way harder than what's on the quiz or the final, but it would be 40 sine B was 2 pi over 3. I did left 3/4, which would be plus 3/4, and the midline was at 20. Blech. If you want more practice on writing equations, I think there was a couple on that spare trig sheet that I had. Yes, did I mess something up? Did you do a left shift like this? One? No. Because, yep, let me erase this one more time. The entire cycle from the top to the top finishes at 3. So halfway here is 3/2, and half of that again is 3/4. So you either had to go 3/4 to the left or to the right. If you did it to the left or to the right, it would have been a negative sign. But that's way gross compared to what's on the quiz. All right. I changed this. Originally, you had to write the equation and then plug it in your calculator and find a value. And for the sake of time and the sake of not getting multiple points wrong, I just have it write the equation, okay? So it's not as worth as many points. Develop a cosine equation to model this situation. Charlie's on a Ferris wheel and his friend is timing the ride. He starts the watch when he's at the highest point. Oh, nice. So right away, we're right on the x-axis at the highest point. And that's 32 feet in the air. All right, if we draw a Ferris wheel whose radius is 14 and the highest you ever go is 32, what is the lowest you go? 28 all the way across, right? Wouldn't that leave 4 down here? Did I do that right? 4 and 14 is 32. So I think the lowest you ever go is 4, because that's 28 across, okay? Makes 1 revolution every 90 seconds. Guys, that's the period. Even if there was a phase shift, they're telling you it goes around back to where it started after 90 seconds. So we need to find the midline. 32 and 4 divided by 2 is 36. Divided by 2 is 18. The average is the midline of 18. And this is a distance of 14, which was the radius. And this is a distance of 14. So which goes where? This is where people get them backwards in the equation. What is the amplitude that goes out front? 14. Then it was a cosine. The period is 90, so we could just put a 2 pi over 90 in here, or you can reduce it to pi over 45. I will not be picky about that. It's supposed to be time, but if you put x, I'd be okay with that too. And then the midline is up at 18. This one doesn't have a phase shift, because it said it started at its max. You're welcome. If it said you have to write a cosine or sine for something, it's okay to do a negative sine or cosine. All right, guys? I'm okay with that. All right. Now, I've never done this before. I've always left it where you had to figure this out by just looking at the regular unit circle, but I did put it on here to help you remember. It says that this is negative pi over 2 to pi over 2. So that's in these two quadrants. And you can renumber these, negative pi over 6, etc. Okay? And tangent is the same. Inverse cosine, it says is 0 to pi. This is not the SAT. If you want to use highlighters or colored pens or something tomorrow, you're more than welcome to. All right. So remember, it goes cosine, sine. So sine is a y value, but we can only look where it's green on here. So we can only look in these two quadrants. We're looking for a y value of negative pi over 2. That's right down here. Now, I didn't renumber all these, but the second one is called what? Negative pi over 4. Would everybody get that right? Okay, and then I don't know that there's 2 on the quiz, but I put another one on here for practice. Inverse cosine is -1/2. That's where the cosine's -1/2. And remember, cosine, we had to look in quadrants 1 or 2 between 0 and pi. So that answer is 2 pi over 3. Questions? All right, this is an inverse question, but it's a sketch question. This is basically very similar to what we asked at the very beginning of this about draw and tell me the values. So it says we have some tangent, some angle whose tangent is 15/8. It's positive, so it's quadrant 1. Tangent is opposite over adjacent, so 15/8. We need to do Pythagorean theorem. Is it 289? And then the square root of that is 17. Did I do it right? Okay. And then what does it want, guys? This was all just to help you draw the triangle. It wants what now? The sine of that. The sine is opposite over hypotenuse, which would be 15 over 17. I hope these are seeming easy now. When we go back and do this stuff. All right. These are easy, but maybe a little tricky. There's not 2 of them on the quiz, but this says 2 times the sine times the cosine. So you're supposed to find the one that says 2 times the sine times the cosine. But it says to simplify this, you take whatever theta was and you take the sine of 2 theta. Well, our sine of 2 theta, what was our theta on this question up here, guys? 6x. So if you wrote that, I wouldn't count it wrong, but it really should simplify to the sine of 12x, okay? Either one I would take. Does anybody see where this one comes from? 2 cosine squared minus 1. Two cosine squared minus 1 is this guy way down here. And it says to put your number and say cosine of 2 theta. So it's the cosine of 2. What did ours have instead of a plain theta? It had a 3 theta. So that could simplify to a cosine of 6 theta. Everybody okay with those? No? Yes? Okay. I can pretty much guarantee you that the one on the final is one of these double angle identities, okay? It's not anywhere else on that reference stuff. All right. This is a solving a trig equation where you have to factor. It says use an appropriate algebraic method, that would be factoring, to find the exact solutions of this trig function. All right. To get a 2 sine squared, you need a 2 sine in one parenthesis and a sine in the second, in another parenthesis, doesn't matter what order. What are we trying to put factors of at the back? We need factors of 1. So they're 1 and 1, but it needs to make a -1. So if we FOIL this back together, I get 2 sine and 1 sine. Which one do I want to be negative so that the middle term comes out -1? I need the 2 sine to be negative. Everybody okay? I think you'll have plenty of time. You know, if you're worried about time, skip this question and come back to it if you're not good at factoring, okay? But take the time to check your signs, because it's just wrong if you get them all wrong because of signs. All right, if I FOIL this back together, I get back to this. And then I have to play the equal 0 thing. So we have 2 sine x plus 1 equals 0. or sine x minus 1 equals 0. When we solve this, we'll get a negative 1/2, and this we get a positive 1. What if it had like sine equals 5? Or even 3/2, right? Can't happen. So you would only have less solutions. Be careful. What does this mean? We don't need any plus or minus anything. We just want the ones off the unit circle. So the sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. And then our other one was the sine is 1. And the sine is positive 1 only at pi over 2. I see people erasing. Did I mess up the signs? I don't think so, did I? Okay. All right. I'm going to go quickly through this one. It would take you more time on the final, but you have to do Pythagorean theorem to find the hypotenuse here. Everybody with me? So you'd have 7 squared plus 24 squared equals, and it comes out 625, which is 25. And while I'm at it, I'm going to do this one. This one, you're looking for x when you know the y and the hypotenuse, so you would subtract. And you'd get 144, which is 12. All right, then you fill these in. This one uses this figure, and you're actually looking at the angle in here. That's the reference angle. So the sine is opposite over hypotenuse, or 7/25. The cosine is adjacent over hypotenuse, or negative 24/25. Be real careful, because if you mess these up, then there's no shot you're going to get the rest of it right, okay? The sine on this guy over here, opposite over hypotenuse, would be 5/13. And the cosine adjacent over hypotenuse would be 12/13. Watch your signs, okay? All right, this says what trig identity are we going to use? So all you have to do there is copy it down. It said sine A minus B, so it's this one. And I don't care if you copy it down with A's and B's. I guess I'll go ahead and use alpha and betas, because that's what it has up right over here, but I wouldn't count it wrong. Okay, anybody remember what the most common mistake people make is? When they get here, they write this, the sine of, and then they put in the numbers from up here. Okay, but that's not the way it works. The whole sine of alpha thing becomes what number? 7/25. And then it says times the cosine of beta. That's this one. So we have 12/13. But do you see what I'm doing, guys? I'm just substituting in values. I don't need the word cosine and sine anymore. You're substituting in the value of the function. Cosine alpha was negative 24/25. And then the sine of beta was 5/13. This is one, you know, I'd put a little star by and come back and triple check if you have time at the end that you didn't make a mistake substituting stuff in. But then you literally just go to your calculator and type it all in. It doesn't matter if you're in sine or cosine, in radians or degrees, because you're just doing, you're not using the sine and cosine buttons. All right, someone tell me what you get. I really won't want to take time to do this. (204/325). Was the last one 5/13, guys? Me too. Don't leave it a decimal because you'll have to round. It's not exact unless you make it a fraction. Questions? All right. This is simplify, and it says which Pythagorean identity did you use? So 1 plus cotangent squared is this one. So that's what you write on this blank. Now, for this particular example, we didn't have to even rearrange it, right? Sometimes you have to rearrange them. And you could write it either way here, I wouldn't care. But 1 plus cotangent squared is just a cosecant squared times a sine squared times a cosine squared times a secant. I didn't do any trades yet other than that. And then what do we need to do? I would make them all sines and cosines. Now, you do remember your very generous teacher put those on the reference sheet, right? What is cosecant? It is 1 over sine, but this one is squared. Then it happens to say times sine squared, which right away those cancel out. And then it says cosine squared times, and what is secant? 1 over cosine. And if you don't put the thetas, it's not a big deal. But what is that becomes when you multiply then cosine squared over cosine, and I don't care if you write it out like that or you just reduce it right away, but it should reduce to a cosine. Everybody good one way or the other? I don't care how you show your work, just show that you did the trades, okay? Questions? That's all it is. There's not a nasty, like, get a common denominator one or anything, okay? All right. Degree mode. You are supposed to know these, but they may be on your reference sheet somewhere. All right, this triangle ABC. What's wrong? Yeah. 15.6 is angle A. Side B would be across from angle B. It says is 125. Side C over here is 65 units long. Those are not degrees, okay? And then find side A. Okay, what is that asking you to use, guys? Law of cosines, because you have two sides and an angle in between, okay? In particular, since you're trying to find side A, it would be this one, but A squared equals, you know the sides are 65 and 125 minus 2 times 65 times 125 times the cosine of 15.6 degrees, and of course I ran out of room. I'll just put the screen on here when I get it. Okay, but I need to be in degree mode, okay, which I am. And then I'm going to type the whole thing at once. Don't mess it up by trying to do some craziness. Because when you do it in pieces, unfortunately, sometimes you do it wrong. 2 times 65. Am I using the right numbers, guys? Do I remember them right? Times the cosine of, was it 15.6? Okay, now that's one of the answers, but it's not the final answer, right? Because this is A squared, so we still need to square root. So A is 64.8. So we got A squared was 4198.6, and then we square rooted, and we got A is 64.8. Questions? All right. This guy, again, we have a triangle ABC. I don't know what it looks like. A is 42 degrees. Angle B is 95 degrees. As soon as we know two angles, we know the third, right? 180 minus 95 and 42. I'm thinking we might need that. minus 95 and 42. Got 43 degrees over here. Because then it says side C is 75, find side A. We can use law of sines as long as we find that 43-degree angle, right? So then we'd have the sine of 43 is across from a side of 75, and the sine of 42 is across from a side of A. Then you just cross multiply. And I would never write out all this work. I would just type it in, but just in case. And then you would divide by the sine of 43. So, ew, this calculator's not in degrees. So 75 times the sine of 42, close parenthesis, divided by the sine of 43. I got 73.6. Did someone else get that? Questions? All right, just a couple extra practice on factoring. Before you can do anything, these have to equal 0. This one factors 2 sine. Actually, I think that's going to be a minus. And 1 sine and 1, but we need it to end up positive. Did I do that right, guys? What happens on this one? What can you do there? Take out a cosine, and that would leave 2 cosine minus 1. So here you have the cosine is 0, which is at pi over 2 and 3 pi over 2. And this would be the cosine is 1/2, which would be at pi over 3 and 4 pi over 3, guys? 5 pi over 3, yes? Someone check in? Is that right? What? Say it again? Yeah. I was just going back, sorry. I don't know, doing it in a weird order. This would be pi over 6 and 5 pi over 6. And the sine is -1 would be down at 3 pi over 2. Did I do those right, guys? No mistakes? Okay. There are some extra copies in the back. If someone is in a position where they need to do really, really well on this final and they're nervous, take an extra copy and go home and do it tonight.